Hello, this is Gabriela Carrera, and this is Lab 1 for Physics 2, which is the tape experiment. So the purpose of this lab was to determine the amount of charge that is generated between the two strips of tape once they are rubbed against each other, and this charge causes them to attract. Let's see if there's a video and if it will work.
Wait. This thing's not gonna work.
Okay, so first of all, tell me how you prepared the tapes. I want to know that first. You have to know.
What, should we just try it?
Go ahead and
Try and see what it
you take a few tapes and pull it apart.
Yeah.
All right, okay.
Can I just hold it over it? Oh, it doesn't work.
So yeah, you can see the experiment right there. So there are some relevant formulas and background information to know. Let's see if I can turn on my little cursor. Sorry. Here we go. So, oh, that didn't work. That's not working. I'm sorry. Okay, so basically we have this formula here because at the end of the day, what we're going to end up doing is balancing the force of gravity against the force caused by the electric field. So that's this formula here. This E is the electric field formula, and this Q is the charge. And then some other relevant formulas just for the other force that we're calculating are just the gravitational force is equal to mass times gravity. So our procedure was that we took two pieces of tape of equal length and stuck them together. We made sure that they were completely stuck together by rubbing them together and just ensuring that there were no bubbles or gaps. And then we unstuck the tapes really quickly, and then without handling them a lot, we placed one below on the books, kind of hanging down, and the other was like lowered down on top until it attracted up, and we recorded the distance between the two tapes where the lower tape responds to the movement of the upper tape. So one of the questions that we're asked in this lab is what approximations are we making in order to calculate for this charge? So let's go through these three. We are, in fact, ignoring air resistance. It would be such a minuscule amount considering like the small scale here, but air resistance is something that you technically should account for. F drag in like a real world scenario, but we're not doing that for simplicity's sake. We are also treating the long tape as though it's a point charge. Obviously the tape is very long and we're only using like the points where they, like just the very centers of the tape. But next week we're going to test as if it wasn't a point charge. And then we are also assuming that every tape has the same amount of charge evenly distributed. Just basically an ideal scenario. So this is some of the math that I did before getting started on the code, and this kind of guided me and allowed me to check my work. But you can see that I found the force in between the two charges, the distance, the electric field caused by one acting on two, and then this is some of the math that I worked through, so you can see that I solved for the force of gravity, and that I just basically rearranged the equations and solved for Q at the end, rearranging this equation here. And this is my final answer, which eventually does match up with the GlowScript code. So here's the code. You can see here that there's a visualization where the orange arrow is the gravitational force, the green arrow is the electric force, and the blue arrow is the electric field vector. And in terms of my code, it's mainly broken up into two segments where this is the part that really is calculating our numbers, and then everything after that is really just generating this image that you're seeing to the right here. Notice that there's the electric field vector, which involves r vec and r hat. And then there's also, more importantly, because it's what we're using in our final calculation, the force acting on this lower one by the upper one. So the results were that the magnitude of the charge in the tape matches with the result I got by hand, which, sorry, should have been written again, but it's this number right here, 1.75 times 10 to the negative 7. And the possible sources of error would be overhandling the tapes, which we'll talk about next. So it's important to handle the charged tapes as little as possible because human skin is polar. We're comprised mostly of water, so we do generate a charge, and every time you touch the tape more, you're ruining the charge distribution that we're testing. So it's really important to touch it as little as possible. And I also think it's really, really interesting, and the reason that I added this picture is that this is also the science behind how a touchscreen works. You're basically completing the circuit within the phone, which is why if you put on rubber gloves or something that's insulating, you can't use your phone. So if electrons had a positive charge and protons had a negative charge, the signs of the charges for the respective pieces of tape would switch, but the rest of the experiment would proceed the same way. Because like either way, the positive and negative charges are attracted to each other. So basically, the tapes will still attract. It's just the number on the sign of the charge that we're associating with each piece of tape would flip. Thank you very much for your time.